Now I am. Okay. Hi, my name is Lena Scogna, and this is Team Genius.
Jesse Brewer.
Luis Mendez.
Sebastian Otano.
And Evelise Rodrigues.
Prior to starting the project, our team members took the time to go through each of the lessons provided by the manufacturer. After getting comfortable with those lessons, we broke down what each section of the project was asking for, and decided how to create a code designed to program the Arduino boards in a way which they measured what we needed. Due to the current pandemic, we were only able to have Zoom meetings to discuss how each measurement should be calibrated and performed, which we will discuss later in the video.
For this project, 3 systems were built to measure distance, water depth, and temperature. Each system was constructed to do and complete the following requirements. The temperature system was to contain an LCD display that showed temperatures ranging from 0 to 100 degrees Celsius. The ultrasonic sensor would measure distances between 5 to 50 centimeters with the dial display. And lastly, the water level detection sensor would acquire water depth between 5 to 50 millimeters with a dial display as well.
Hello everyone, this is the distance measuring project. Here is a schematic of the system. The system consists of the Uno R3 board connected to the breadboard with the ultrasonic sensor module and the servo motor. During the project, we're going to be measuring a distance of 5 centimeters and 50 centimeters from the ultrasonic sensor. When we move the object closer or further away from the sensor, this is going to create a rotation in the servo motor. The steps to build this system, I use previous knowledge gained from the servo motor and the distance exercises. This combined with a quick YouTube video was enough to complete the project. The problem that came up was finding an easy way to visibly read the servo motor output. This was mitigated with 3 nails and some hot glue.
Hello everybody, this is the water depth project. Here I have a wiring schematic of how my project is set up. Here I have everything set up. I have the servo and I have the water depth sensor, the R3 board, and the breadboard. Here I have a cup full of water, and as we can see, we're going to go from 0 to 180 degrees depending on how deep the sensor is. So here we go. The steps I took to make this circuit were to take the lesson from the servo and the lesson from the water depth sensor and convert it into one circuit. The problems that I faced in this project were having a consistent code so that the farther I put the water depth sensor in the water, the smoother transition of the servo corresponding to the value.
Hello, I'm going to be discussing the temperature portion of the final project. The system constructed is based primarily off of the Lesson 21 circuit that was provided with the project kit. One of the primary design issues was ensuring that thermal interactions occurred exclusively between the thermistor and the substance whose temperature I was measuring to collect the data. To do this, I used a 5 millimeter syringe insulated with aluminum foil and Dynamat thermal tape. Then, I submerged the thermistor inside the syringe to collect the data. The largest problem encountered was the presence of a faulty resistor. To overcome it, I used the Centec digital multimeter first to identify it, and after a quick switch, the temperature sensor was starting to read fine. And as you can see, it is indeed increasing when it comes into contact with something.
To calibrate the system, I measured 5 centimeter increments all the way to 50. This data was collected and stored into an Excel sheet. Then a trend line was created. This was used to help calibrate the system.
To calibrate my water depth sensor, I would have 5mm increments until the sensor is completely submerged at 40mm, and I would use the lesson from water depth to find the value that I'm given as an output, and then I would make a chart so I would know what value corresponds to what depth, so that way I could write my code.
To calibrate the temperature sensor, I used water whose temperature was steadily increasing to a boil, a Taylor kitchen thermometer, and then once again, the insulated syringe. What I would do was that I would measure the temperature of the boiling water with the thermometer. Then I would collect some of that water and quickly rush over to the thermistor to immerse it and then get the reading. Once data collection was complete, I plotted the data onto Excel, and using its features, I found a trend line. Once I found the equation, I just plotted that into my code, and now I have an accurate and calibrated thermometer.
This experiment shows just how versatile the engineering career field is, from coding to hands-on building of the experiment to gather the data.
This experiment helped me learn how to use the calculations to my advantage to make a code. One scenario that this task helps in engineering is by learning how to debug codes and running multiple things at once for better efficiency.
This project was certainly an exercise in problem solving. Everything from discovering the presence of the faulty resistor to ensuring that thermal interactions occurred exclusively between the thermistor and the water whose temperature I was monitoring. I'm certain that I will be able to apply all of these skills in the field someday.